Welcome everybody to today's webinar from Continuant. My name is Chris Parker. I'm the Director of Professional Services for the EMEA and APAC regions. So just before we get started into the main webinar, it's just a little tiny bit of housekeeping to go through. This session is being recorded and we'll be posting it online so that you can watch again on demand at your leisure. In addition, a copy of the slides used are available right now from the GoToWebinar control panel, so feel free to download them and keep them as reference. Additionally, I'll be showing a small demo during the session. In the demo, I don't go into a great sort of level of technical detail on the installation steps and configuration. However, I've recorded a supplemental training video that walks through that setup. You're welcome to view that in your own time, and we'll send a link out to that training at the end of the session when we send all the other information out to you. Okay, so in today's webinar, we're going to take a look at how you can expand your existing Tungsten cluster using the standalone replicator to replicate out of the cluster into a different environment, such as an analytics environment. First off, we're just going to have a quick recap of how our products work, and then we'll look at how the replicator can be used as what we call a cluster slave. We'll take a brief walk through the benefits that Continuant Solutions deliver to your business, and then we'll close with a Q&A session. So feel free to ask questions as we go through the GoToWebinar control panel, and we'll go through them all at the end, and I'll give you the answers as we go. So by the end of today's webinar, my aim is to answer these three simple questions. So what is a cluster slave? Why should I consider a cluster slave, and what targets can I actually replicate into? So let's start with a quick recap of the two solutions that we have, so the Tungsten clustering and Tungsten replicator. So the clustering supports all varieties of MySQL, such as Community Edition, Picona, and MariaDB, and it's probably our flagship product. It's a solid and stable product, proven track record, and over 12 years of development and counting. Provides you with a solid solution to protect your MySQL databases whilst ensuring continuous operation and providing zero downtime maintenance operations and things like that. Tungsten clustering can be used in a wide range of use cases, single standalone clusters to our more complex composite multi-master topologies, with many customers with clustering in place in a mix of environments from on-premise to cloud and a hybrid mix of the two. In addition, last year we also launched the first version of our dashboard, allowing you complete control and visibility of all your business's clusters in a single place. So let's just zoom in a little bit more on the clustering. So we've got a number of existing customers on the call, and I know many of you will be familiar with this. However, let's just take a quick, deeper look that make the cluster. First, we have the database nodes. For clarity, we have the master in the middle, which is the green node, and we have the two slaves either side, the blue nodes. On each host, we have the manager and the replicator. So the manager is like the brains of the cluster. All of the managers communicate with each other and with all the other components. And they're constantly monitoring everything, including the host and the database itself. So in the event of a failure, the managers come together and make the decision on what to do, whether that's a failover to another node or an attempt at auto recovery. The replicators, well, they're responsible for moving the data. Each replicator can operate as either an extractor, which is what the master would be doing, or an applier, which would be on the slaves. And that role will automatically change based on the communication from the manager, such as during a failover or a manual switch. We'll look at the replicator on the next slide, as this is more relevant to today's topic. Finally, the connectors sitting up there at the top, they're like the intelligent proxy, routing your client connections to the underlying cluster. There's many configuration settings and different ways that the connectors can be set up. They can simply just act as a basic pass-through, so what we would call bridge mode, or they can be more involved in the routing decisions, such as sending read-write traffic to the master only, balancing read-only traffic amongst the slaves, for example. So all of these components, they work together to provide the benefits that I mentioned, such as the zero downtime maintenance, high availability. However, what we often hear from customers is that they didn't realize that the replicator component can operate as a standalone product. And that's what we want to talk about. So first, it's useful to understand how the replicator works. So the role that the replicator takes on in a cluster, that's controlled by the manager. So the manager will decide whether it's an extractor or an applier. In a standalone installation, we configure the replicator at install time, either as an extractor or an applier, and that's assumed based on a number of parameters that we pass during the installation and also dependent upon what your targets and your source is. So how do we move the data around? Well, the extractor reads and processes the MySQL binary logs, and as transactions are committed, we extract them from the binary logs and convert them into our own native format known as THL, or transaction history log. And we always maintain transactional consistency, and we only extract complete transactions. So once written down to THL, the job of the extractor is done. At this point, all the slaves in the configured topology will pull the THL from the extractor, and we then convert that THL back into SQL statements, which are then applied into the correct sequence to the target database. Because we're in control of this THL and it's our own format, we're then able to take this and apply it to any of our supported targets. So we don't have to write this back into MySQL. So we've got that control. So with this in mind, let's take a look at a cluster slave. So a cluster slave node, it's a node that's external to a cluster that receives one-way feed of replication from the source cluster. So the cluster slave is configured in such a way that it sees the entire cluster as the source rather than being tied to a specific node. So the applier node doesn't even know or care which node is the master. Instead, we actually set the preference to pull THL from a slave node within the cluster. Being cluster aware means that the source of data to our target can change automatically depending upon the source node availability. So if the node that we're pulling THL from goes down, the cluster slave will automatically just pull from one of the other nodes. It has that complete visibility. So as for the THL, well, the cluster's already generating the THL. So all we're doing is effectively just adding an extra endpoint. We're actually pulling it, but it's the same kind of concept. The replicator will come online, pull the THL that's already been generated. We're just then reusing existing information, so we're not having any additional impact at all on your cluster. So why would you consider a cluster slave? Well, they're particularly useful when you have a need for offloading reporting, but you don't necessarily want the overhead of those reporting processes impacting your cluster operation. A cluster slave could also be used as a means of providing a backup, perhaps to seed a QA or test environment. Although recovering a cluster slave backup into your cluster isn't as straightforward as taking a backup from a node within the cluster, it could still also offer alternative solutions. Other common uses for cluster slaves, and this is where today's topic mainly sits, is perhaps when your reporting system wishes to take use of significantly more powerful analytic systems that require access to the data, but via different target. So, Hadoop, Vertica, Redshift. So using the powerful heterogeneous capabilities of the replicator, remember I mentioned that we have control over that THL, so we can apply it wherever we want because we know what it is. It means that we can extract from your cluster, feed it in real time into any of our supported targets. And they're all listed here. So you see, obviously your cluster will either be the MySQL Community, Enterprise Edition, Percona, or MariaDB, and your targets can be any of what you see on here. So we can go into any of these. There's also more complex topologies that we can use. As mentioned on the previous slide, we've already got the THL, so we're just going to use that wherever we want. So you could have, say, multiple independent clusters in your business, but you want to consolidate subsets of data from each of those clusters into a single analytical system. And we can do that for you in what we call our fan-in topology. So we pull the THL from all of the clusters. We can use the filters to include or exclude tables, even right down to column level. And we can then merge that data into one single place in your target. And we do have a number of customers that already do this. Additionally, let's go for the reverse of that. You could have one large cluster, but you have two different teams responsible for doing reporting on different areas of data. But those two different teams use two different solutions. One may use Redshift, one may use Kafka. So what do? Well, we have that THL. Using the filters, we can say, right, this data from this bit of THL needs to go to this target, and this bit goes off to this target. So what we call our fan out. And that kind of leads me quite nicely onto a demonstration to show you this working. So what I've actually got set up is a single cluster called NYC, and I've configured a cluster slave node just using a standard EC2 instance up in AWS, and I've configured 2 applier services. So replicating out to Kafka and another replicating out to Redshift. So I'm not going to go into great detail on the process of installing and configuring this topology. As I mentioned at the start, there is a supplemental training video that's been recorded that goes through all of the fine details of installing and all the configuration parameters. I just want to show you how this looks in a working environment. What I have in my source cluster, I've got 2 databases, one called Zoo and one called HR, and I've set the filters up so that changes to HR will go through to Redshift, and any changes to Zoo will come up through to my Kafka queue. So all a single installation utilizing that THL generated by the cluster. So I'm just going to switch my screens. Hopefully you can see my terminal session now. Okay, so what you can see here at the moment, obviously not a lot of text right now, just blank sessions. I have 3 sessions here. This is my cluster node, DB1, DB2, and DB3. And over on this screen here, I have 3 screens. These two screens are connected to the same host, my cluster slave host. And this screen up here is connected to my Kafka host. So first of all, I don't want to spend too long and labour the point here. I'm just going to go into ccTRL just to show you that I have this cluster, that I have DB1 is currently my master, DB2 are my slaves. You know, everything's good. My cluster is automatic. We're online. Everything's happy. So then I'm just going to jump over to my cluster slave. So I've already installed the replicator. The replicator is up and running. I can just do a quick replicator status. Okay, everything's running. So we then can look at trepctl services. Okay, and we'll have 2 services here. We have the REPL to Kafka, and we have REPL to Redshift. As we can see at the moment, my Kafka service is offline. That's intentional. I keep having problems in my demo environment. My Kafka instance keeps stopping, so I just decided to stop it, and I'll just start it when we need it for the demo. And then obviously REPL to Redshift is coming down to Redshift. If I go into look at this in more detail, so we can look at the service and we'll do status, so we can see the full details here. So what's important here is we can see the master connect URI, and as you can see, we have all the nodes in my cluster listed, so DB1, DB2, DB3. At the moment, because we're offline, we're not actually pulling. So what I'm just going to do is I'm just going to start up my start up Kafka over here. And then what I will do is I will bring this online and then look at the status again. Okay, so we can see that currently we're pulling from DB2. So we've gone through this list. It's identified DB1 as being the master. We have a preference to only pull from slaves. So it's found DB2, DB2 is online, and we're good, we're happy. Okay, so what I'm going to do now is I'm just going to attach to my Kafka consumer up here, and I'm going to connect into Redshift over here. Okay, so I've got my Redshift set up. I've already got some tables in here, a table called employees. Oops, I forgot I'm in effectively a Postgres console. Okay, so there's my table, my employees table, and I have the staging table. Obviously, the Redshift applier is what we call our batch applier. So we actually write out to CSV onto S3, which then gets loaded up as change data into the staging tables, and then gets merged up into the base tables. Okay, so I'm just going to go back to my cluster, and I'm going to connect to my master. So I'm going to do TPM connector just to show that we are on the master DB1. Yeah. Okay, so first of all, I'm just going to use the Zoo instance, and I'm just going to do a couple of inserts into tables over there. And if I jump back here, we can see that they've come through on my Kafka queue as the JSON messages. Okay, inserts. Yeah. That's basically what we look like when we replicate into Kafka. We have the operation type, insert, sequence number, which is the entry in THL, and then we actually have the record details. So all the column names and their values, and then at the end we have the source schema and the source table. Pretty straightforward, right? And let's just do a quick update on there, and I'll do a quick delete on there so you can see what they look like as well. And you can see we've got the update has come through, and the delete. Yeah, okay, straightforward. Right, let's look at Redshift. So Redshift, I'm going to use HR, and I've already got a number of records in this table. I'm just going to insert a few more. Let's put a couple in there. And then if we go over to here, so I'm just going to bring up the status of Redshift. Okay, we can see everything's looking good here. We're online, and obviously this one is actually, this pipeline source is DB3, so we're actually sourcing from a different source here. And if we select star from stage XXX, we can see it's already processed the first insert I did, but the second insert, this is the change data, so it's insert, and then we have the relevant information that we load at the tag at the beginning. So the operation code, the sequence number, the row ID, and the timestamp, and then we actually have the row data. If I look at the base table, oops, I need to qualify this. We can see that it's there, 106 and 107, which are the two that I inserted. And just to show you what an update looks like, because with our batch applies, we don't do updates. What we actually do is we convert an update into a delete followed by an insert. So what I'm going to do here is I'm going to give all my employees a nice little pay rise of 10%. And if we come over to look at our staging table, we can see lots of deletes, followed by lots of inserts, and that's what it would look like. And then once that gets processed, all of that goes up to the base tables. Okay, so that's pretty much straightforward. That's showing that data's coming through, and we didn't see any activity on Kafka when I was updating HR. It's because I've got that filter set up, so I'm saying only HR goes to Redshift and only Zoo goes up to here. What I want to quickly do now is I'm just going to very quickly exit out of here. I'm going to put my cluster into maintenance mode. And I just need to remind myself of the pipeline source for Redshift. And we see the pipeline source is DB3. So what I'm actually going to do is I'm going to take the replicator on DB3 offline. So replicator DB3 offline. So this is currently where that cluster slave is pulling its THL from. The replicator goes offline. So what happens? The replicator is automatically updated and is now pulling from DB2. Zero interruption to your service there. So if something's happened on the cluster, the replicator will just go, oh, well, I'll just go find another source. Obviously, your entire cluster goes down, then that's a different story. But as long as there is at least a node running, this cluster slave will just keep going. Okay, so let me just flip back to my PowerPoint. There we go. Okay, so that's the demo over, and as you can see, I mean, it's very straightforward. One service sending your data wherever you want it. There's a lot of technical setup in that. You know, and as I mentioned, do watch the supplemental video that will explain how that's configured, and it'll show you the configuration and all of the various steps to get that running. So let's just have a quick recap on Continuous Journey and the solutions we offer as we get close to the end of the webinar. So if you're an existing customer and you've been with us for some years, as many of our customers are, then this may not be too much new information for you, but please bear with me and I'll keep this brief. We're very proud of the solutions that we provide, specifically our clustering solution, enabling your business critical applications to run on a global scale with zero downtime. And our customers come to us from a range of industries, from SaaS, e-commerce, financial services, gaming, telecoms companies, and they rely and trust on our solutions to safeguard their annual revenue. We're also very proud of our first-class support services, offering our full 24/7 coverage, for all of your customers. If any of you have had to raise an urgent case, and I'm sure you'll appreciate the fast response times that you get from our team. I think on average last quarter, I think our response times for urgent cases was around 5 minutes, and in some cases it was even less. Continuant, we've been around for 15 years. We had a small diversion back in 2014 when we were acquired by VMware as part of their roadmap to build a DBaaS solution. In 2016, VMware made a few decisions that altered their product strategy. So at that point, we spun off from VMware and we returned to a new independent Continuant that we are today. The future for Continuant is looking strong, and coming up this year, we'll soon be launching our own Tungsten Cloud offering. So keep an eye out for announcements and future webinars as we get close to launching that as well. I'm not going to labour on this slide. It's just a small selection of some of our bigger customers. As you can see, the variety of industry sectors covered here is quite impressive, from telecoms and finance and everything in between. So to summarise our solutions and what we've discussed today, Continuant offer our clustering solution, allowing business critical applications to achieve continuous operations. Our standalone replicator product allows you to distribute your data from either standalone MySQL instances, or as we've learned today, from your existing clusters, and replicate that data in real time to a wide variety of targets, including Hadoop, Redshift, Vertica, and many, many more. Also, we'll soon be launching our own replicator AMI in the Amazon Workplace. So this will provide you the ability to fire up appliers and extractors quicker than ever before, and it'll give you full control over a more streamlined billing process tied into your existing AWS infrastructure. And finally, as I alluded to on the previous slide, we'll also be launching our own Tungsten Cloud solution, bringing all of these solutions neatly together with simple, fast deployment and management facilities. Okay, do we have any questions? Let's have a look. Okay, we've got one here. It says, can clustering be used with RDS or Aurora? Simple answer is no. Let me just expand on that a little. RDS and Aurora, obviously, as you know, they're managed databases, and we don't have access to the underlying host. So we cannot really install the manager component to control those nodes. We need the manager on the same host as the database. Also, with RDS and Aurora, you don't have access to the binary log as such. I mean, you do, but it's in a different kind of format or a different pathway to get to them, and you have less privileged accounts. So whilst RDS and Aurora are perfectly valid targets for a cluster slave, and you can use the standalone replicator to replicate from and to RDS Aurora as source and targets, the limitations don't enable us to cluster around it just yet. But it is something we are currently investigating, and I know our development teams are making progress on that. So keep your eye out. Maybe there'll be a future release that will allow us to do that. How do you provision the data? That's actually a really good question. It mostly depends on your target and whether you are applying any filtering. It can also depend on how much data you have. For a cluster slave that's a MySQL target, then the quickest way would just be to use a backup of a node from within the cluster. The replicator tracks position. You might be familiar with the trep commit seek node tables. We track that, so we can simply restore the database, position the applier, and it will pick up from the point that was last written to. For non-MySQL targets, it can be a little more complex, but it's not totally impossible. We have a tool called Tungsten Provision THL, which effectively streams data through the replicator, generating new THL, which we can then load through the applier. And for Hadoop, we also have the possibility of using Scoop. But to be honest, the best thing to do is say it really does vary on your target and data and filtering. So if you contact us specifically about your use case, and then we can help guide you the best way based on those requirements. Two questions here, very similar. How do you get the replicator to continue applying after the target goes offline, and how do I recover if the applier gets an error? So I'll cover them both. They're kind of on the same track. The main thing to keep in mind here is THL retention. So this is a property within the replicator that controls how long THL is kept for. So if your target goes offline, providing it's not offline for longer than your THL retention period, then when the target comes back online, the replicator will simply carry on where it left off. Obviously, as I mentioned with the previous question, we're keeping track of that position. So it'll come online, it'll just say, hey, where did I last apply, and off it'll go. If your target's offline for longer than that, then you're kind of stuck. If you've lost THL and you've lost binary logs on your source cluster, there's not a lot we can do. So you would need to, you'd be in a position there looking at reprovisioning. But the main takeaway is have good monitoring, keep THL for a good period of time, disk space depending. Now, if the replicator is in an error state, which was the second question, when I did the TREPCTL services, the status command, you'll see there's pending error code and pending error seek now. I think there's a few little bits of information there, so that it will tell you there why it's gone into an error state. If that's not obvious, you can look through the log files. Assuming you can see the error and it's a fairly obvious one, it could be a data related, then you could simply just skip, use the skip option to skip the transaction if you feel it's safe to do so. Sometimes you could just simply try bringing it back online and letting it retry. That sometimes works, especially if there was a network blip that brought your replicator down. But otherwise, make use of our support. Provide the logs, a diag, and the support team will be able to assist you and help you get you back online. Okay, I think that's it. I don't see any more questions, so I'll wrap up. Just want to say, thank you. I hope you found it useful. If you would like more information and you'd like to set up a POC to test any of the solutions, do get in touch. Our contact details, contact us at sales@continuent.com. There's links here for our training, webinar library, white papers. A lot of the things I've talked about are in the documentation, specifically some of the answers to your questions about THL retention and things like that. That'll be all in the documentation. So once again, thank you for your time. My name was Chris Parker. My contact details are there. Please do get in touch. We enjoy hearing from you and helping you. So I hope wherever you are, you enjoy the rest of your day. Thank you and goodbye.